All right, now we're going to talk about extraneous solutions. So squaring each side of an equation sometimes produces a solution that is not a solution of the original equation. These are called extraneous solutions. One of the reasons for this is because when you square something, it ends up being positive or zero. So if the answer you get ends up putting a negative in the square root, then it's not going to work. Or you end up with a negative inside the square root. Or if the square root comes out to be equal to a negative number. So let's go through an example and a couple practice problems to show you what you need to do. So the whole point of this is you always need to check your solutions in the original equation. So let's solve square root of k plus 1 equals k minus 1. So in this one, the radical is already by itself. So you start off by squaring both sides. Now, when you square the right side, you can't just write k squared plus minus 1 squared. You have to square the whole side, which means you need to put parentheses around the k minus 1 and square it. Excuse me. Now, the k minus 1 squared is not k squared minus 1 squared. You actually have to do k minus 1 times k minus 1 and FOIL that, okay? So that's what they did here. Now, if you FOIL it, you do k times k is k squared minus k, then inners would give you another minus k, and then the last would give you plus 1. So these two would subtract together to give you k squared minus 2k plus 1. And that's what they got there, okay? Now, what you have to do is, now it's a quadratic equation. You have to subtract the k and the 1 to the right side and set it equal to 0, okay? Then you could just factor that. You just factor out the GCF of k, and you get k times k minus 3. Since it's set equal to 0, and remember, you can only use the zero product property when you have a product equal 0. If it's a product equal any other number, you can't do this. You set each factor equal to 0. Set k equal to 0 and k minus 3 equal to 0. So I already know k equals 0. If I just add 3 to both sides here, I get k equals 3 as my other solution. Okay? So now I substitute in both of those numbers to check in the original equation. So I'm doing them both at the same time. If I substitute 0 in and substitute 3 in. If I substitute 0 in, I get square root of 1 equals negative 1. Well, that's not true. And on this side, I get square root of 4 equals 2. Well, that's true. So negative 1, or excuse me, k equals 0 does not satisfy the original equation, and 3 is the only solution. You would say that 0 is an extraneous solution. What that means is it's an extra answer that you get that doesn't actually work in the original equation. And again, the reason is because when you square both sides, everything becomes positive. But then when you check it back in the original equation, you might end up with a negative under the radical or a square root equal to a negative number, which you can't have either of those, okay? So here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So this one, you start off by squaring both sides, and you would have t plus 5 equals t squared plus 6t plus 9. Then you subtract t, subtract 5. So those cancel, and you have 0 equals t squared plus 5t plus 4. Okay, then you could use the quadratic formula, or you could factor it. So I'm going to factor. You get t plus 4, t plus 1. Remember, when you factor, you're looking for numbers that multiply to the constant and add to the coefficient of the t term or the x term. Okay, so 4 and 1, multiply to 4 and add to 5. Set both of those equal to 0. Oops. So t plus 4 equals 0. T plus 1 equals 0. So here you get t equals negative 4. And here you get t equals negative 1. Now I have to check it in the original equation. So I'm going to check negative 4 first. So negative 4 plus 5, does that equal negative 4 plus 3? Well, I get square root of 1 equals negative 1. So 1 equals negative 1. No. So that means negative 4 is an extraneous solution. Now be careful. Just because one of them is an extraneous solution doesn't mean the other one is automatically an answer. It might be. It might turn out that both your answers are extraneous solutions, and then that would mean there's no solution to the equation. It might turn out that both of them work, and then there'd be no extraneous solution, but there'd actually be two answers to the equation. Okay, or one could work and one could not. All right, so you have to check both all the time. So if I check -1, so -1 plus 5 in the square root, does that equal -1 plus 3? So this would give you square root of 4, and this would give you 2. And square root of 4 is 2, and 2 equals 2, so that's good. So t equals -1 is the only solution, and t equals -4 is the extraneous one. Okay, so let's do 3b now. Square both sides, because the radical is already by itself. Okay, so you would get x squared minus 6x plus 9 equals x minus 1. Subtract x, add 1, you get x squared minus 7x plus 10 equals 0. So I need numbers that multiply to a positive 10 and add to a negative 7. That means both numbers have to be negative. And the factors of 10 are either -1 and -10, but those would add to -11, or -2 and -5, which do add to -7. So, oops. So we're good there. I said 5, but we're at 7. Set each equal to 0, so x minus 2 equals 0, so that means x equals 2. And x minus 5 equals 0, so x equals 5. So then I substitute those in. If I plug in 2, you get 2 minus 3 equals square root of 2 minus 1. So you'd have -1 equals square root of 1, -1 equals 1. So that's not true. So 2 is the extraneous solution. Then if I substitute 5 in, you 5 minus 3 equals square root of 5 minus 1. 2 equals the square root of 4, and that's true. So x equals 2 is an extraneous solution, and x equals 5 is the actual solution. So the answer to this equation, x equals 5. All right, well, that's it for this section. Please continue on to your assignment, and as always, reach out to me if you have any questions. Take care now.